Hello learners, I will discuss igneous textures, processes and pathways with a special reference to aphanatic and phaneritic textures. These are the two important varieties of igneous textures. What is aphanatic texture? By definition, aphanatic texture consists of group of variety of crystals too small to be identified by naked eyes, implies high crystal nucleation rate. This signifies high crystal nucleation rate. Second one is aphanatic rocks, are those rocks which display aphiric or non-porphyritic textures, indicating that the magma superheated above liquidus temperature. These are the two important definitions, and I will cite few examples of the igneous rocks here which show porphyritic aphanatic texture. I am citing an example of andesite. Andesite is a variety of igneous rock. It is in the form of a lava flow, which is also commonly known as andesitic lava flows. Andesitic lava flows in hand specimen show phenocryst of white color, which are mostly of phenocryst. See here in the slide, this white colored plagioclase phenocryst is lying within the black colored glassy ground mass, and black hornblende like in a gray aphanatic ground mass. The hornblende is actually black in color, which you cannot see in this background, because the background you have glass which is also black in color, but white phenocryst of plagioclase is clearly identified. How it looks under the microscope? So, see the photomicrograph showing phenocryst surrounded by microcrystalline matrix. This is a microcrystalline matrix formed largely of small microlites of euhedral plagioclase. This is all euhedral plagioclase crystals. See here, I have marked also plagioclase phenocryst with corroded core. The core is corroded. Corroded means the part of the crystal is eaten away by the magma, or it has undergone dissolution in the magma. Plagioclase that are interwoven in a felty texture. This entire plagioclase is interwoven. As I said earlier also, texture is the interwoven of the grains. The grains are how the grains, mineral grains, they are interwoven with each other. So, these plagioclase grains, they are interwoven with each other, and they give rise to a variety of texture which is known as feltic texture. Now, I am citing another example of porphyritic aphanatic texture in basalt lava. Basalt is also a lava flow. It is intergranular texture of aphanatic ground mass. An interlocking network. Interlocking network means the two grains, they are interlocked, and the interstitial space is occupied by magma. An interlocking network of randomly oriented plagioclase microlites and abundant plagioclase and Fe(Ti) oxide, that is iron titanium oxide grains, they form the interlocking texture, and in between these interlocking grains the glass is occupying that open space. Then euhedral subhedral olivine phenocryst is present. This is actually a subhedral or euhedral phenocryst grain, which is lying within this kind of felty texture of the andesite, except that mafic minerals are more abundant in this. Now, how it looks under the microscope? Aphanatic texture, entire section is microcrystalline. I am citing an example of East Pacific rise specimen here. The entire section of microcrystallites and no phenocryst. There is no phenocryst. Phenocryst means large size crystals are absent in this, totally absent or altogether absent, but you have the entire minerals, they are crystallized which are microcrystalline. Microcrystalline means they are not much of bigger size, neither they are of a smaller size, they are in between large and small size crystals. So, cryptocrystalline texture are too small to be resolved optically. Even under the microscope, the cryptocrystalline texture, it is seen here under this photomicrograph. This is under high resolution, almost 100x. The photomicrograph showing microlights. These rod-like minerals, they are often called as microlights, and they are of plagioclase and pyroxene crystals, which is marked over this photomicrograph. Then felty texture. Felty texture is a texture which contains microcrystalline rocks in which elongate rectangular grains. These are all elongated rectangular grains of feldspar are dominant. The plagioclase microlights are large enough and interwoven in a felty texture as in basalts and andesites. These two types of textures, they are commonly found in two types of rocks, which I have already stated earlier. They are basalt and andesites. Now, I am citing an example of felsitic texture in another rock. Aphanatic mixture of felsic minerals such as feldspar and quartz also occur in dacite and trachyte. Here I am citing an example of the same kind of texture, but in different types of rocks, which is called as dacite and trachyte. Both the rocks, they are of volcanic rocks. Here the dacite, how it looks under the microscope: hemicrystalline, fine to coarse grained, anhedral orthoclase. This is an orthoclase. And plagioclase grains, matrix showing banded appearance. This matrix, it shows banded appearance. Here I have drawn the bands with my own drawing, and how it looks under the microscope, and based on microscopic observation I have drawn the figure here, where I have shown you a band. Bands are glassy and undergone devitrification. These bands are glassy, they have undergone devitrification, and as a consequence iron oxide is released in the form of a dust. That is why you get turbidity in this section here. This kind of texture where you get turbidity produced by devitrification or alteration of iron oxide, we call it as eutaxitic texture. Now, another variety of felsitic texture, felsitic microcrystalline porphyritic aphanatic texture in a intrusive granodiorite. Granodiorite is another igneous rock. It shows weak oscillatory zoning. Somewhere here it shows weak oscillatory zoning, while rotating the stage the plagioclase grains shows concentric rings, and these concentric rings, they are changing their polarization colors from dark gray to lighter gray shades while rotating the stage. So, plagioclase is showing oscillatory zoning here. This kind of feature can be seen in a rock which is called granodiorite, which shows felsitic texture. Now, I am discussing another variety of texture which is known as trachytic texture. Trachytic texture means rough in feel. While you put your fingers over the outcrop, you may feel a rough feel, and rough feeling is because of the feldspar microlights are oriented in a particular direction as seen in trachyte. While putting your fingers in one direction, you feel smooth, while you put your fingers on the outcrop in opposite direction, you may feel rough, because the microlights are oriented in a different direction. So, holocrystalline, by definition, trachytic texture is holocrystalline fine to coarse grained rock showing inequigranular texture. See here, the rod like minerals, they are oriented parallel to the east west direction of the crosswire of the microscope, this direction. And here is the plagioclase feldspar, here is the epidote. Epidote is also a mineral, silicate mineral, and here is a reabsorbed biotite. This biotite shows reabsorption, and reabsorption is again because of the alteration of the minerals. Now, I am talking about the intergranular texture, randomly oriented microlight plagioclase and abundant pyroxene, iron titanium oxide and olivine grains form interlocking mosaic texture. See in this photomicrograph, you see here The abundant plagioclase, this is plagioclase and this is pyroxene, the colorful mineral which shows high order polarization. High order means second to third order polarization color. This pyroxene and plagioclase, they are abundantly present, and in between this abundantly present these two minerals there is a space. That space is occupied by black colored glass. So, this glass and the crystalline minerals, they show interlocking texture. Glass is being interlocked between the spaces formed due to the lying of the different types of minerals in the rock. Another variety of texture is intersurter texture. Intersurter texture is because of the disposition of the minerals. These are the minerals. Minerals means crystalline minerals. These crystalline minerals, they are disposed in a glassy matrix, and the space left out of the disposition after disposition of the minerals, that space is occupied by black colored glass, and this kind of texture is known as intersurter texture. This texture is similar to intergranular texture, except brown glasses interspersed among microlites of the plagioclase. This is called intersurter texture. Then I am citing another example of intersurter texture, but in a different rock. The rock here is basalt. Basalt contains plagioclase. These are the plagioclase grains. These plagioclase grains, and adjacent to plagioclase grains is a pyroxene grain. These two mineral grains, they are embedded within the glass, which is black in color, and this glass is actually interspersed, giving rise to intersurter texture. See here another example of a basalt thin section. Here the basalt is chiefly composed of plagioclase, rod-like plagioclase grains. They are oriented parallel to the north-south crosswire of the microscope. This is north-south direction of the crosswire of the microscope, and other minerals such as pyroxene, this is pyroxene, and plagioclase, this plagioclase and this plagioclase, they are there in the slide. And based on this observation, I have drawn this observation. This is my field of view. I am showing a hand drawn picture here, where I am trying to show you agate, olivine, brown glass, and all these minerals, crystalline grains, they are embedded within the glass, giving rise to intersurter texture in basalt. I will sum up the entire discussion. I have already discussed aphanatic textures. How do they form? What are the processes? They are held responsible for the formation of such a variety of textures in these rocks. Thank you, viewers.